Alrighty, everybody. How we doing tonight? It's Joe. Let me lower this a little bit. Thank you for joining me tonight. Lower the mic. Just a little bit. Alright, how we doing, everybody? Hope everybody's doing quite well. I want to thank everybody out there for following the last couple days. My boy, Dork Chop. Thank you very much, my good friend. You're an amazing dude. And then who do we got? We got Jamil93. Good looking out. Guys, I'm at 47 followers right now. 47. That gives me 3 away from 50. 3 away. Let's get me across that finish line, guys. One thing that might hold me up is my average viewership. That might be the only thing that might be holding me up from getting affiliate at this point. But you guys have got me at 47 followers, giving me 3 away from 50, pushing me towards that goal of finally becoming an affiliate on Twitch. So, help me out, guys. Let's get me across that finish line. Let's get me to 50 followers. That way we can start doing some bigger things, all right? I've been working, let me see. I know I didn't end up streaming last night. I end up going to bed with the wife and stuff like that, spending some time with her last night. And don't get any crazy ideas either, guys. Let me see. I did end up working. I ended up doing some more schoolwork last night too as well, which was good. I'm finally done with my English class. I'm on the humanities now. That humanities class doesn't start till the 12th, so that ought to be interesting. I looked at the syllabus. The syllabus is kind of, I don't know. Some syllabuses are easy to understand and some aren't. This one is not. I think it's about arguing, how to constructively argue with somebody. That's fine. That's cool, I guess. Ought to be interesting. So that's coming up on the 12th. So I should, like I said, I finished the last couple of assignments this morning, I guess you could say. It wasn't last night. It was early this morning. And then I also, because I've been trying to, the Discord, again, I've been working on the Discord, and I know you guys are going to say, I got some cool stuff up in the Discord right now. I got some. I was working on it. I was working on that too. Again, because I've been promising you guys that I'll be inviting people and giving out the links and stuff like that to it soon. I am. Trust me. I should just start putting it out. Let's see, guys. Let's see. The reason why I've been holding off on it is because I want to make sure that once you guys come to it, you guys can see what I've been trying to do with it and what it is. It's going to be like a portal. I don't know how, just make sure this is open up on this one. There it goes. That way I can monitor the chat from here. It's gonna be like a portal that you guys can source a lot of information from. I got Reddit. I got a whole bunch of Reddit hooks going to it to keep you guys updated on some pertinent information, at least on some of the stuff that I find interesting, like CCNA, VMware. That reminds me, I gotta get like a Cisco hook in there. I'll do that too. I also find I got a meme hook going to it too, so you guys can get some of you guys can check out or just go to town, wasting your life away looking at memes for days. That's the only channel that I have that is going to be it's going to ask you for your age appropriate, and what is it, NSW, whatever. But it's going to ask you for your age just because obviously I'm not going to be monitoring the language and stuff like that in that meme channel. But that's about it. That's the only one. Just to give somebody some, just to give everybody that comedy value, I guess. I love comedy, guys. And I always love a good meme. But again, some of the memes that drop, that will probably drop in that meme channel. Probably will be maybe offensive or something like that. So I'll apologize ahead of time, but it's gonna ask you, it's gonna tell you that it's age appropriate meme channel. So yeah. Other than that, let me see. I'm kind of running behind again today. I just woke up. Legitly, my wife called me. She's like, "Listen, dude." She's like, "You gotta wake up." She's like, "You gotta get your tuchus in the shower before you start streaming." I'm like, "Whoa! I guess I gotta run." So, yeah. So I got coffee and I got a hot pocket. Everybody's having hot pockets for dinner since I didn't have enough time to obviously make a full course dinner tonight like I usually do. Which is fine. We can have a night of hot pockets. Love me some hot pockets. So, all right. So tonight we are. Where's that music coming from? Here, another music too at the same time. All right. Tonight we're gonna be we're gonna start off with a big review. All right, since we've gotten all the way through part 1, part 2, part 3, part 4, and now part 5, we have some big reviewing to do. So this should hurt me. This should beat me up pretty well. So we're gonna dive right into a big review this morning. This afternoon, and then from there. From there, we'll start talking about OSPF and stuff like that. And you guys know I like to end a part. I don't like to begin a part over a weekend, but we might start it though. Just because again, I kind of feel like we're behind. We're kind of behind on where we should be at right now. So we might jump into reviewing OSPF and stuff like that. And then doing some labbing on OSPF and stuff like that too at the same time. But yeah, that's gonna be the synopsis. That's kind of like the syllabus of tonight. We're gonna do a review. All right, so we're gonna jump over to the Pearson test program. I know you guys have seen me do this a lot of times, but this is it's what I need to be doing. I need to continue to be reviewing these questions, these subjects to really make sure that I'm ready for the actual exam when we take the exam. So yeah, so let's do it. Let's do it. All right, let me drop this down. Let me kill the music so it doesn't distract me personally. Pull this up. Yeah. Over here. Yeah, work. Come on. Work. Work. How's everybody doing out there today, though? Hope everyone's doing good. Hope everyone's having a good day. Oh, come on, man. Work for me. Yeah, but like I said, I'm super pumped up that though, guys. It's probably not gonna load, is it? I'm super pumped up that you guys have gotten me to 47 followers, guys. This is amazing. You guys are awesome. All you guys are awesome out there. There, I don't know. I want to thank you guys so much for getting me this far. This is a big hurdle, big leap in this channel, guys. All right, now I gotta switch over. Drop this down. Yeah, so welcome everybody again. Welcome to all my YouTubers. Welcome to all my Twitchers out there and anybody watching on Facebook. All right. So what we'll do, we're gonna do a pretty hefty review because we need to. All right. Uh, Again, I have to ensure that I'm really I'm beating myself up. I gotta continue to beat myself up, guys. You guys don't understand, like, um, I'm awful. And I want to make sure that I am completely prepared for this exam when I take it. Because I will beat myself up so much if I'm not. If I take the exam and I beefcake it, I will be so unhappy with myself. So, all right. So we're gonna do a pretty hefty review here on a lot of these subjects to really nail down some of this fundamental knowledge that we got going on here. Whoop! Wait, my eyeballs. Take a sip of some seltzer water. We're gonna jump over to the whiteboard view. Oh, you know what I need? I need Epic Pen up. Let's get some Epic Pen up in here. Where's my? Wait, oh, there it is. Epic Pen. Right. Guys, I made some funny emotes. You guys got to check them out. You guys will check them out. Once you guys get me to 50 followers, guys, we're gonna have to eat my hot pocket at the same time we're doing all this. We drink some coffee too. All right, let's get over to the whiteboard view. What is it? What is that right there? Oh, that's the Tetris pieces. My moving Tetris pieces. Let me pull this back up so I can monitor Chizad again. All right. All right. We're in there like a swimwear. Working. This mouse is working. Okay. I love these things, guys. If you guys ain't never had one of these before, these are well, if you guys ain't never seen one of these before, these are like they're just handheld keyboards, but it's got a cool little mouse pad. I love this thing though, guys. I use this thing a lot. Especially when I do scenes like this, when I'm whiteboarding and interacting at the same time. It's invaluable, guys. I love this thing. Let me just turn off these lights. That way they don't die on me. I gotta get some better lighting, I guess. Not so much like white lighting, like I got that down because I got studio lights, but what I'm saying is, I guess, like colored lights or whatnot, just to add some of the, no, that's not what I'm trying to say. What I'm trying to say is to add like adjusting the light to how everything looks. I guess I don't know. I'm rambling a little bit. All right. Yeah. What, man? Let's do this. Let's do what they say. All right. Let's do what it say so I can make sure I'm staying on top of chat just in case anybody had any questions as we go. Phone. Board. I can see it at the same time. Hopefully it doesn't fall. Don't fall, phone. Alright, that way I can see chat and everything at the same time. So, alright. Clear this up. Alright. That's done, that's done. Let's get into it, because it's going to be pretty hefty. Alright. Woo! 102 questions. Alright. A user has sent a request to the server. What is the A user has sent a request to the server. What process does the server go through to determine what services is being requested by the user? So de-encapsulation. All right, de-encapsulation. It's going to open that frame up and take a look at it. All right. Which of the following terms represent a layer, an L3 PDU in the OSI model, which includes the network header and its encapsulated data? Okay. So that'd be a packet. So that's a packet, because remember, a frame is a layer 2. A packet is a layer 3. A segment is a layer 4. Okay. All right. The term segment refers to which layer of the which layer PDU. So that is the transport layer PDU. Okay. IP functions at what layer of the OSI model? So IP functions at the network layer. Okay. Network layer. All right. The output comes from a network analyzing tool. It lists a group. It lists a group of lines in each header of the PDU with the frame data link header on the top. Then the next. All right. So we've read this before. In describing line A. All right. From the graphic, which OSI model, within OSI model perspective, which is the correct label to be used in combination with the PDU. So Ethernet 2. So this is layer 2. Okay. This is looking at MAC addresses. So we have the destination MAC. We have the source MAC right there. Okay. All right. So this would be the frame. All right. All right. Because datagram. No. All right. So it'd be the frame. So this is the frame. Okay. All right. We have another one. Same thing. All right. It's just it's a pull out from a network analyzer tool like Wireshark or something like that. It's just looking at the packet, the frames here. So based on the packet capture shown, which of the following is true? All right. Line C corresponds to the transport layer in the TCP/IP model. Line D is used in connection to establish a termination. Flow control. Line A is used to path routing. No, that's layer 2. Line C is used to route packets through the internetwork. No, I mean it's gonna be C. It's the transmission control protocol. So the TCP. All right. But let's read the rest. Line B is related to formatting data into frames appropriate for transmission on the physical layer. No, that's all right. Let's keep it moving. All right. Remember, guys, just hit me with questions if you have any time. All right. From the output of R1, which of the following is accurate? So R1. All right. Let's take a look at what we got here. All right. The address of all right. So some MAC address is designed to assign to a single network interface card and never duplicated or different. So yeah, that's true. All right. The hardware address field represents the 32-layer. The hardware address field. So hardware address field represents a 32-bit layer 2 address. R1 will use the address. No. It's saying that it's going to use the layer 2 as a layer 3 address. No. R1 has learned the IP address in less than 1 minute. No. All right. So the address is designed to assign to a single network interface card and never duplicated on a different NIC. All right. Let's keep it moving. All right. All right. We're doing good so far, guys. The network in the figure uses Cat5 cabling with RJ45 connectors. Which of the following statements are true about the wires inside the cabling inside the RJ45? So this is going back to how these network interface cards logic is on. It goes back to the logic of PCs. So PCs routers and access points all have the same type of logic, where switches, bridges, and hubs all use their own type of logic, okay? Because those items are all related to one another, okay? All right. The cabling from PC1 to switch 1 connects to, nope, because we're going to be using straight through cabling. The cabling, and we got to select two answers. The cabling from switch 1 to switch 2, pin 2 to pin 3, no, it'd be pin 1 to pin 3 and pin 2 to pin 6. The cabling from switch 1 to switch 2 connects to pin 6 on one end, pin 2 on the other. That sounds pretty good. PC1, S1, switch 1, nope. Switch 2 to R1, yep, that's good. And nope, okay. So we got R2. So we got pin 6 to pin 2, and we got pin 6 to pin 6, okay? All right, refer to the diagram. The new connections that are going between campus 1 and campus 2, routers is required to provide 500 megabytes per second of bandwidth. The routers are located 3,000 meters away from each other. Which standard of Ethernet should you use in the situation? So let's think big. So when we think big, we think Zulu, okay? Remember, these are hard to remember, but I'm just going to keep it in my mind where Zulu means big, all right? So the 802.3 Zulu, all right? That's the 1 gigabyte, 1 gigabyte, 1 gigabyte Ethernet. No, it's not 1 gigabyte Ethernet. It's 1 gigabyte, it's 1 gigabyte Ethernet 1000 based LX. It's fiber optics, and it can go out for 5,000 meters. So that's what the 802.3 Zulu represents, okay? Well, is. In the figure, Cat5 cabling with RJ45 connectors used. Which of the following statements are true about the wires inside? All right, so we read that again before. So cabling from S2 to S1, pin 3, PC, nope. So the cabling between switch 1, PC1 and switch 1, nope. PC1, switch 1, 6 and 6, yep. So it's that one. I'm only going to select one on that one. Same thing, same question, same type of question. Let's answer it again. PC1 to switch 1, pins 1 to pins 1. We got to select 3 on this one. That's one. That one's right. Switch 2 to switch 2 to switch 1, 1 and 3. That sounds pretty good. Select that one, and switch 2 to switch to router 1, pin 2 to pin 2. Yep. And then this one's wrong. This one's wrong. And then finally that one's wrong. Okay, so it's the first 3. Okay. All right. Which fields are in the IPv4 header? Which fields are in the IPv4 header? We got to select 3. So we got protocol, time to live, and DS. Okay. All right. A device uses MAC address 46EE, which is part of the MAC address, indicating the original network equipment vendor, okay? So it'll be the first half, guys. So it'll be the first half, okay? All right. The diagram shows a simple internetwork in which which all LAN connections use fast Ethernet. Select the answer that lists the correct cabling type. Okay. We got to select 2. All right. So a crossover cable between switch 1 and switch 2. Crossover cable between switch 1 and switch 2. That sounds pretty good. All right. An Ethernet crossover cable between a rollover cable. An Ethernet crossover cable. No. Okay. So we have a crossover cable between the 2 switches and a crossover cable between the switch and the hub. All right. All right. This diagram refers to which type of fiber cable. So we have multimode. All right. Again, because the core, bigger core, and it's representing, it's showing, it's illustrating that light wave is bouncing. Okay. So we're gonna go with multimode. All right. The circle field part of the Ethernet header lists the value of hex 0800, which in this case means that the Ethernet header follows Next, as shown in the below the circle field, what is the name of the circle field? So we have the type. Okay, I believe it's type. Yep, it's type. A user host at. Woo! I had a feeling it was gonna fall. You see me catch that fast? I got my cat-like reflexes. That was fast. I was like, wha! Caught that in my hands. All right, let me get some coffee real quick. I'm like a ninja sometimes, guys. I'm like a ninja. How's everybody doing though? All right. Oof, coffee good. More coffee we need. All right. A user at host 10.3.0.1 powers on a device, issues the ping at 10.3.0.2 command. What is true about the ARP request sent to 10.3.0.1? All right. User at host powers on a device, pings the command. What is true about the ARP request sent to the frame will be de-encapsulated only by the device. The device will process the reply with the unicast address frame sent to the host. This is part of DNS. Host 1 is attempting to learn. So host 3 is the host 10.3.0.1 is attempting to learn layer 2 addressing information. The device will process the request and reply with a unicast frame from host. So that one right there. Okay. All right. Which of the following data link protocols are used to encapsulate data in a lease line? So we have PPP, point-to-point, and HDLC. All right. High-level data link control. Okay. All right. Which answer lists an Ethernet-based WAN service? So we have E-line and Ethernet over MPLS. Okay. All right, a lease line provides layer 1 service, okay? Because it's physical. It's a physical service, okay? All right. All right, in the figure, all devices, well, all my YouTubers just dropped off immediately. Come on, YouTubers. Show me some love, baby. I guess they didn't like the fact that I dropped my phone. All right. In the figure, all devices are statically configured. They might have been chatting. I just don't pay attention. That might have been. I'm sorry, YouTubers. All right. In the figure, all devices are statically configured with an IP address and mask and default gateway information. Assuming that all switches and PCs have just completed a reload, the switch MAC address tables are empty, the PC's ARP tables are empty, and none of the PCs or the routers have sent frames yet. Which of the following is true? So we got to select 2 answers. Okay. All right. So when PC1 pings PC2, the first packet will be sent is a ICMP echo request. No, it won't. When PC1, where's PC1 and PC2? So they're right there. Okay, so they don't even have to cross a router. They're just going through switches. All right. When PC1 pings PC2, the first Ethernet frame will have PC2's MAC address as the destination MAC. When PC1 pings PC2, the first Ethernet frame will have no, it won't. When PC1 pings CC2, the first Ethernet frame will have a broadcast destination address. When PC1 pings PC2, the first Ethernet frame will be an ARP request. So that one's right, and then this one's right. So the first Ethernet frame will have a broadcast destination address, okay? All right, because they don't know each other's layer 2 information yet. All right. All right. Which protocol finds an unknown layer 2 address from a known IP address? That would be ARP, Address Resolution Protocol. All right. Based on the diagram, host A sends a packet to server B. The two serial links use HDLC, while the rest use Ethernet. How many times will the packet be experience re-encapsulation by the router? So we have 1, 2, 3, 4, 5. Okay, so we have 5 times. All right. How does the receiver of a HDLC frame know what has been encapsulated within the frame? All right, it's in the type field header. Okay. All right. Using a cable to connect a workbench PC to the console port of a switch. You notice that the switch is not responsive. A coworker mentioned that that same PC was used with the same switch earlier the day. The system LED on the switch is green. Considering the given scenario, what should the technician do? Verify the correct physical connections have been made. So we're going to select 2 answers. Verify the cables used as crossover cable. Verify a straight through cable. Make sure the cable is a rollover cable. Check to see if the cable uses Cat5. So we have to make sure it's a rollover cable. All right, and verify if the physical connections have been made. Okay. All right. Yep. Okay. All right. If an engineer issues the copy running config startup config command, which Cisco memory type would the configuration be copied to? So that's the NVRAM. Okay. All right. Excuse me. Oh, what's up? So this is the ABC WAN. So this is the actual Pearson test prep program that I'm using. I have a subscription. To O'Reilly Media, and it gives me access to every single one of Pearson's actual test preps. And this is the full gambit CCNA Pearson test prep program that you can buy individually. So you can buy this whole entire package individually, and it's actually pretty expensive. But I have a subscription. Again, my subscription to O'Reilly Media is pretty expensive as well. It is actually really, really expensive, but it gives me full access to so many things. So to answer your question, this is the Pearson test program, Pearson test prep program that I'm using right now, and we're reviewing chapter 1 to chapter 18 of the CCNA official cert guide. All right, so we're doing the 1 through 4 quiz questions. So it's given us 102 quiz questions of the chapters 1 through 18 right now. So that's what we're reviewing. Okay. All right. What is the name of the Cisco iOS command line exec mode that allows a user to run more powerful commands? So that is in the enable mode. All right. Hope that answers your question. Welcome to the stream, my friend, and thank you for the. Let me see. You get the little captain hat. That means you're a follower. I believe so. All right. All right. If an engineer has completed a series of changes to a Cisco switch, no, that was crazy. Siri started picking that up right now. If an engineer has completed a series of changes to a Cisco switch, drop that down. Pick that back up. All right. And he wants to ensure that the changes have been saved and retained across repos. Which command would so that'd be the copy startup config running config. All right, the copy startup config running config. Okay. No, wait. Copy running config startup config. Woo! Boy, I almost beefcaked that one. Copy running config startup config. All right. That'll save it. So this is taking the configuration that is running in the current RAM, and then it's saving it over to NVRAM. Okay, that's what we're doing. Okay, copy running config, startup config. All right. When the Cisco iOS command line is initially accessed via console telnet SSH with no privileges, which mode is the user placed in? So that is in the user mode. All right. Your switch is in a air-conditioned, locked wiring closet on the first floor of a building. There is a card reader on that door that allows only authorized personnel in the room. On Thursday, you use Telnet to connect to this switch and issue the following command: hostname S1 and log out. Okay. So on the Monday morning, you Telnet over the switch and run the show version command, and you see the following. And then you also see that the name of it it retorted back to what it originally was because the engineer didn't save the configuration to NVRAM. Okay, you forgot to commit the changes and automatically rolled back at nope. You forgot to save the configuration to NVRAM. Exactly. All right. All right. Refer to the diagram. Which of the following connection parameters are used when connecting to the console of a Cisco switch? So that's 9600, 8 and 1, 9600, 8 and 1, 9600, 8 and 1. Can't forget that. There's my little jingle to that one. All right. What is the default aging for a MAC address table entries that have not been used yet? So that's 300 seconds. All right. What type of memory does the switch use to build the MAC address table? All right, that's the TCAM. Okay. All right. What will a switch compare its MAC address table to be able to forward frames? All right, so that's be destination MAC addresses. All right. So what will a switch compare it in its MAC address table to forward frames? Okay, so that's the destination MAC addresses. Okay. All right. After power on, need some more coffee. After power on, a frame arrives at a switch. The switch had not yet learned the source MAC address of that frame. Which action must that switch take in this case? The switch adds the source MAC address to its MAC address table. The switch adds the source and destination. Nope. Switch checks the nope. Switch nope. All right. So the switch adds the source MAC address to its MAC address table. All right. How does a switch build its MAC address table? By listening to incoming frames and examining the source MAC address. By listening to incoming frames and examining the source MAC addresses. Okay. Host A. All switch ports reside in VLAN 1. With no port security nor static MAC address tables entries defined. Host B remains powered off, but all other hosts can ping each other successfully later. Host B powers up and the user pings 10.1.1.4. Command generate host B's first network traffic. Which of the following is true? So remember, if host B hadn't powered on yet, then it's going to be, when it pings 10.1.1.4, got to remember that ARP message is going to be going out first, okay, and that's going to be it's going to be broadcasted out because it needs to find some layer 2 information. Okay. All right. The frame will be forwarded out. Switch 2's gigabit 0-1. Yep, it will be. All right. Even though here's the host right here at 10.1.1.4. Okay, but it's still going to be forwarded out. Switch 2. The frame would be forwarded. Nope, it's going to go to switch 3. The frame would be forwarded to host 8. Yep, it'll be frame. All right, the frame would be forwarded to host 8. The frame will not be forwarded to host 8. Yes, it's going to go to host 8 too. So it's going to go to everybody, lottie-dottie. All right. In the figure, all devices are statically configured with IP addresses, mask, and default gateway information. Assuming that all switches have learned the MAC addresses of all devices in the figures. PC1 pings PC4. PC1 pings PC4 and PC receives a reply confirming that the ping worked. Which of the following are true about the frames sent in this network and their encapsulated packets? When considering a frame, consider the header and frame, and any encapsulated packet as well. Okay. All right. So what do we got? Frame that contains the ICP, the frame that contains the ICP echo reply sent by PC. PC4 will have the destination MAC address of PC1. Nope. The frame that contains the ICP echo request, the ICP echo request sent by PC1 will have the destination MAC address. Nope. The frame that contains the ICP echo request sent by PC1 will have the destination IP address of, what's its IP address? No. The frame that contains the ICP echo request sent by PC1 will have the destination MAC address of 500 on the frame that's sent. Nope. The frame that contains the ICP echo request sent by PC1 will have the destination MAC address destination. All right, hold on, let me read. The frame that contains the ICP echo request will have the destination. So it's going to be this one. So the reply sent by PC4 will have the destination MAC address of will have the destination MAC address of 500 on the router. The frame that contains the ICP echo request sent by PC1 has the destination IP address. Yes, it will. Oh, I got that one wrong again. I always get this one wrong. I knew it too. I felt like I knew it. All right. All right. Let's read the next one. All IP addresses are configured for the PCs, and they are connected. They are correctly connected to the network. The MAC address table on the switch looks like this. PC. So it looks like we don't have a MAC address table. We don't have a MAC address for the actual PC. PC4. All right. So PC4 has learned the layer 2 address of PC3 in its ARP table. PC4 sends a unicast ping request to PC3 as shown in the packet capture. The output, yep. What will the result of the ping? What will be the result of the ping request? Okay. The switch will filter the frame but not forward it. The switch will flood the frame to PC3. Yep. Switch will reply. Switch will flood the frame. No, so it'll flood it. All right. A local user Bob has been created on the switch and forwarded and following output on a local user has been created on the switch, and the following output is from the same switch. Okay, so crypto key, mypub, RSH. Yep. Okay. Bob has an IP address on his computer and can ping the interface on the switch. SSH is enabled online on the VTY lines, but the user Bob cannot log into the switch via SSH. What needs to be added to the configuration? So we have a domain. They created the RSH key. So it requires local authentication. An engineer logs into a device to perform some troubleshooting. The engineer expects to need to repeat many commands. So he wants to ensure the device remembers the commands in the device's history buffer for easy recall. Which of the following would ensure this behavior? All right. So what do we got? So okay. So if he was on, so it'd be terminal history size, and then on that it'd be history size right there. All right. Which command will generate an SSH encryption key? Okay. So that is crypto key generate RSH. Crypto key generate RSH. All right. Which two of the following actions provide the best security for accessing for accessing a router's privilege mode remotely? All right. Which of the following actions provides the best security for accessing a router's privilege mode security? So configure the enable secret command, and then enable SSH and disable telnet accessing using the telnet, using the transport import SSH on the VTY lines. Selected. All right. Which answer encrypts the password that will be required of a user after they type the enable exec command? Okay. Which answer encrypts the password that will require, so that it'd be an enable secret? Okay, the enable secret. All right. In the figure, the 2960 switch has been taken out of the box, and cabled, and PC1 can communicate through R1 with the rest of the IP network. However, no configurations has been added to the switch 1 to switch 2. As a result, the network engineer sitting at the management station to the right of R1 cannot ping or telnet to switch 2. Which of the following configurations, when entered in correct order on switch 2, allows the network engineer to ping or telnet the switch 2 from the management station? Okay. So we need to assign it. We need to make a management VLAN, and then we have to assign it an IP address. Okay. So he wants to go to switch 2. Okay. Select 4. Base VLAN 1. Default router. And then no show. All right. The exhibit shows some configuration commands that sit in a text file. After adding this configuration to the switch, the user will attempt to connect with username Fred and password Hope. Which of the following best describes the accuracy of the configuration for allowing a user attached to subnet 10.1.1.0/24 to SSH to the switch? All right, so the exhibit shows the configuration command that sits on it. After adding the configuration to the switch, the user attempts to connect using the Fred. Okay, let's take a look at the exhibit. Right. All right, so they don't have the login local. The configuration needs the login local instead of login on the VTY lines. Good. All right. As an administrator, you decide to change the password periodically on the switch. You enter the following command: enable password Bubba123. The next time you telnet to the switch, you are prompt for a password, but Bubba123 is not accepted. Why? You should have been the enable password. The enable password was set. All right. So the enable password that was set is not in the VTY password command. So yes, that's it right there. All right. Refer the diagram. If auto negotiate of the speed and duplex between host A and the switch failed, what should be the resulting speed, assuming sense failure in duplex? Okay, so if the duplex of host A and host B failed, so it's going to be retorting back to the lowest speed in duplex Okay, so it'll be 10.5. Okay. Refer to the exhibit based on the information shown in the exhibit. What can be said of the configuration on Gigabit 0-4's interface? 0-4. It's been set to half in duplex, half and speed 100. Duplex half and then speed 100. All right, think about it in my hot pocket now that it's probably cold as hell. All right, dinner time, boys. Refer to the diagram. Assuming auto negotiator is enabled, what would be the resulting speed and duplex of the link between switch and host A? The switch and host B, I mean. So it'll be 100 and full. All right. Refer to the exhibit. Both switches are both switches are Cisco switches. What would be the state speed and duplex of the link referred to the switch 1? So auto negotiate fails, but switch 1, because switch 2 doesn't use it. So the network engineer had already configured it for speed 1000 and duplex full. So it'll be up 1000 and full. In front of the diagram in the exhibit, which option is a potential reason for the interface state is shown for the Ethernet interface shown in the figure? All right. So the status is down. All right. Different. They have a mismatch on the speeds. Can't tell if they're in different subnets. Because if we're going Class A networking, the Class A could be 10. Network could be 10. All right. What are common local area network LAN 1 problem indicators? So we have collisions and late collisions. All right. Refer to the diagram. If auto negotiate of the speed and duplex between host B and the switch works, what should be the resulting speed and duplex? Host B, so we have 100 and full. Which Cisco iOS command can be used to display which VLAN support are supported over specific configuration of a switch trunk? So we have show interface trunk. Based on the figure, what Cisco iOS command would be used on the switch board to correctly configure switch port 501 to be the access port in VLAN 30. So it'll be switch port access VLAN 30. Easy. All right. Sorry, guys. Finishing off my dinner. In this network, all switches are powered on, and all relevant VLANs have been configured and correctly and are working. Based on the output in the exhibit, which of the following statements are true about switch 2? There's 24 fast Ethernet, 2 gigabits. So it's showing, so 22, 23, 24 must be trunking. It has a whole bunch of VLANs configured. Yeah, all right, so we have some trunking ports. Only 3 interfaces are trunking. So remember, the trunk ports won't show up on that command, all right? So you won't see them. They're there, they still exist, but you won't see them. All right. Refer to the exhibit and diagram to make it possible for all traffic to pass between PC1's local area network and PC2's local area network. The link between switch 1 and switch 2 will be configured as a trunk. The Cisco iOS command, which Cisco iOS command could be used on switch 1's gigabit interface 0-1s to force to actively attempt to a trunk. Okay, so that'd be, let's just take a look at it. So on switch 1 we have dynamic auto. Okay. So we want dynamic desirable. Okay. All right. Switch port mode dynamic desirable. Okay. All right. What is true about the command switch port non-negotiate? Using this command prevents a switch port from being trunked. All right. If connected to a switch that uses dynamic desirable, the name of the switch will not trunk. So we'll go there. Okay. So it'll prevent dynamic desirable from trying to attempt to make a trunk. Okay. All right. Which of the following functions are provided by spanning tree protocol? Which of the following functions? All right. So prevent MAC table instability, prevent broadcast storms, prevent multiple copies of a single frame being looped. Okay. RSTP serves as an improved protocol in comparison to the older STP. Which of the following statements list a feature RSTP does not that does not exist in STP? The criteria used by a non-switch the criteria used by a switch to determine the designated ports on a segment. The criteria used by a switch to determine ports act as a backup role. The criteria used by a switch to elect. So the criteria used to a switch to switch port to act as a backup role. Okay, because remember on RSTP we have backups. Okay, all right. All right. The exhibit shows a diagram of a small switched network. All switches use layer 2 switching and no layer 3 switching. The diagram identifies the root switch 1, and all root ports RP as designated and designated ports in VLAN 10. All switches have the spanning tree mode rapid PBST command configured. The answer list the answers list ports that are either root ports or non-designated ports. Choose the answer that lists RSTP roles that is meaningful for the port in this topology. So we got to select answers. So switch 2 gigabit -2. So let's take a look. It's a backup port. All right. Switch 4 gigabit 0-1. That could be a backup port. Yeah, that could definitely be a backup port. Switch 4. So remember, backups, well, we got to think about this. So alternate can be root. Backups go to access. So let's think about how we're thinking about this again. So so that's wrong. So switch 4 is gigabit 0-1 can be alternate. Okay, that can definitely be alternate. All right. Switch 4 is 502 can be a backup. Yep, that could be a backup. All right. Switch 4 gigabit. So that also could be a backup. But what it's also stating is can this be an alternate? All right. But since it's passing through this hub, you can see that there's a connection all the way through, so it can be actually an alternate. Okay. All right. What is the name of the new RSTP port state that replaces STP blocking? So that's discarding. All right. An STP topology with 3 switches has 1 link between each pair of switch. Which answer best describes the primary decision point as to which the non-root switch has a designated port on the link between switches and which does not? An STP topology has 3 switches. 3 switches has 1 link between each pair of switches. Which answer best describes the primary decision point as to which non-root switch has it as? And so the switch with the lowest root cost would become designated switch. All others would block. That sounds kind of right. That's wrong. That's wrong. That's wrong. Okay. Let's keep it moving. All right. Assuming all default STP settings, which of S3 ports would become root port? What would be the cost? Okay. So which one would become root port? So remember, fast Ethernet has a cost of 19, where gigabit has a cost of 4. So even though fast Ethernet, so this would be root. So switch 4 would be root in this topology, giving the MAC addresses. Okay, it has the lowest MAC addresses. Okay, so even though 502 seems like the shortest path, gigabit 0-1, even though it passes through another switch and has to go through another port on that other switch, it has only a cost of 8. So to be gigabit 0-1 with a cost of 8. All right. In the figure, in VLAN 1, all switches have default STP settings, and all trunks are up and running at 100 megabytes per second. Which statements are true regarding the behavior of STP in the network for VLAN 1 after the STP topology has stabilized? So, okay, so switch 1 is root. In the figure, all switches have default settings on, all trunks are up and running at 100. Which other statements are true regarding the behavior of STP in the network for VLAN 1 after the STP is stabilized? Okay, we got to select 2 answers. So switch 1 is root. Switch 1 is root. The switch 1 will create hello messages regularly based on the hello timer. Yep. Switch 3 SPAR01 would be in the forwarding state. Switch 3. Switch 4 SPAR01 would be designated port. No, that would be root port. Okay. Great measure. Nope. And no. So switch 3 SPAR01 would be in the forwarding state, right? Because we have because 502 would be in the blocking state. This would be root. We have root. from switch 1 to switch 2. And then root. This would be blocking. All right. Yeah, because the other ones would be in the blocking state. Refer to the exhibit. Which other statements are true about the input shown? Which one? Ethernet channel port, port channel, PO1, aggregation. So we're using LACP, okay, port security disabled. Okay. Port channel is non-operational. Let's see. Port security disabled. All right, let's close that again. The port channel Ethernet link is operational. The dynamic Ethernet channel is it's with LACP. So yeah. The remote interface. Let's go with active. See what happens. All right, we were good. All right, we're doing pretty good. When you are configuring the Ethernet channel between two switches, what are two channel group modes that can be configured if one end is using port aggregation protocol. Okay, port aggregation protocol. So we have desirable and auto. Desirable and auto. Okay, because the other one is active and passive. Active and passive. We have desirable and auto. Which spanning tree mode are IEEE standards? So which spanning tree mode are IEEE standards? Okay, PBST and RS PBST plus are both Cisco. Okay, so they have multiple spanning tree protocol, rapid spanning tree protocol, and spanning tree protocol. All right, the two switches are connected by 4 Ethernet trunks. 4 VLANs exist with members in each VLAN on each of the two switches. The network engineer would like to have the switches treat all 4 trunks as a single 400 megabytes per second trunk, with some of the traffic being forwarded over each of the links between the switches. Which of the 4 statements are true of such a configuration? 2 switches are connected by 4 Ethernet trunks. 4 VLANs exist. Each member switches the network engineer would like to treat all 4 trunks members, which is with some of the traffic being forwarded over each link of the switch. Which of the following statements such a configuration? The show span tree. Which of the following statements are true about such a configuration? The show span tree command will list the combined list of 4 links. No, the four trunks can be placed into the same Ethernet channel. 4 trunks can be placed into the same Ethernet channel to achieve this goal. That's kind of right. The show spanning tree command will list the combined 4 links abbreviated with PO. Yes, it will. STB can be used to cause balancing over the 3 of the 4. No. Okay. When configuring interface to be part of the same Ethernet channel, which of the following should you configure identically. Okay, so we got to use speed. No, I don't want to pick it up. Speed, duplex. All right, they either all have to be access or VLAN, so access ports or trunk ports. Okay. The exhibit shows a list of output from a switch. Which are the statements? Which two statements are true? Which two statements are true? The exhibit shows the exhibit lists an output from a switch. Which two statements are true? Which two statements are true? Let's take a look. So it's got a lower priority cost of the default spanning tree protocol. All right, and all the ports are in a forwarding state. The bridge has a lower cost of the default. Yes, it does. We don't know that. The switch is root port. We don't know that, and they're all in the forwarding state. Yes, we do. Okay. What is the priority? Default priority for the switch. All right, so it's 30. I think yes. So I think it's this one. 3200 768. 32 768. Yes, we were right. 32 768. Remember that. Let's implant that in our brains. Ooh, I'm so pumped up that I got that right. But I kind of knew that was right. For which reason was the RFC 1918 address space defined? For which reason was the RFC 1918 address defined? What? For which reason was the 19 address space defined? To preserve, to avoid, to reduce, to avoid delay, address extinction, exhaustion, to reduce the internet routing table size. Okay. What two options are true about IP addressing rules? Select two answers. What two options are true about IP addressing rules? Addresses in the same subnet do not need to be separated by a router. Addresses in the same subnet, yeah, that's true. Addresses in the same subnet need to be, nope. Addresses in different subnets do not need to be, nope. Addresses in different subnets need to be separated by a router. Very good. Okay. If subnetting a Class B network 172.18.0.0 using the subnet mesh 245.245.240 for all subnets, which answers list the address in the second subnet? All right, so now we got to do a little bit of some mathies. Okay. 245, 245, 240, 0. Subnet 172.18.0.0. 256, 240. All right, we got a 16. So we got 0, 16. 32. Okay. All right. So what do we got? Which answers list the address in the second subnet? So what do we got? We got 0. So we're in between these two, so it'd be 15. All right, so our broadcast address would be 172.18.15.255. All right, and we have our address range in this whole range right here. All right. Which answers us the address in the second subnet? All right, so the second subnet would be, so the second subnet to this one would be 172.18.16.0, all right? And then that would go to the range of 31, all right? So that'd be, the subnet would be 172.18, 31.255. All right, so if we're in the second subnet to that would be 31 to 200, and then 16 to 10. Okay, very good. All right, hope you guys saw how I did that. How many usable hosts are there per subnet if you had the address 192.168.8.0 with subnet mask, with that subnet mask 255.255.240. Okay. Figure that one out real quick, guys. Okay. So 255, 255, 255, 240. All right. We have 192.168.8.0, and then we're climbing by 16 over here, so it'll be 0, 16. All right. So our broadcast address would be 192.168.15. So we have a usable range of 192.168.8.1 to 192.168.8.14. So we have a total number of 14 addresses. Okay, 14 addresses. All right. An engineer at the Acme Corporation was tasked with subnetting with the subnetting design for a new branch location. The only information the engineer was given is shown here. Use the 192.168.100.0 address. Plan for 12 subnets. Plan for 12 different subnets of the same size. Plan for each subnet to have at least 5 hosts per subnet. Which answers list the correct number of subnets and host bits that in the subnet mask that would be used as a requirement. Okay, let's get our calculator. All right, so we remember it's powers by 2. So 2 to the let's say 2 to the 4th. See what that gets us. So that's 16. Let's try 2 to the 3rd. All right, so that's not enough. So we have to be in the range of either 2 to the 4th, 2 to the 4th with the subnets, okay, and then we have to be in there. So because 2 to the 2nd, I don't think gets us enough. I think that only gets us 4. Yeah, so 4. So it has to be 2 to the 4th, and then 2 to the 3rd range that we're looking at for subnet and host bits, okay. All right, we can go over that, but we can't go under that, okay? So subnets 2 to the 4th and host 2 to the 4th. That sounds pretty good. We can't go this way, okay? That's two less, and that's 2 less. All right, so we have these 2 right here would be perfect. Okay. All right. The size of a subnet is calculated with the formula 2 raised to h minus 2. Why are the 2 hosts subtracted from this possible size? Broadcast address and the reserve for the subnet broadcast address. 1 host is reserved for the default gateway. No. No. The reserve. 1 address is reserved for the subnet member, and the other one is for the subnet broadcast address. All right, that's good. Select that one. All right, an engineer at the Acme Corporation was tasked with submitting design for new headquarters. The only information she was given is here. Use the 172.20.0.0/16 mass address space. Plan for 400 different subnets of the same size, and plan for each subnet to have at least 50 hosts. All right, so let's do some more math. So we need 400. All right, subnets. So we're gonna go with 2 to the. Let's start with 2 to the 8th real quick. See what we get. It's 2 to the 9th. So 2 to the 9th is what? What was 2 to the 8th? to the 8th was only 256. So we have to be at least 2 to the 9th for 400 different subnets. So 2 to the 9th. All right. Now we need 50 host bitsies. So 2 to the, let's try, what's 4 again? 16, not enough. Enough. 64. So 2 to the 6th. So we have to be in the range of 2 to the 9th and 2 to the 6th, okay, to make this work. All right. Nothing lower, but we can go higher though, okay? So 2 to the 9th and 2 to the 7th, that'll work. This one won't work. 2 to the 10th and 2 to the 6th, that'll work. Okay. All right. Which of the following addresses could be used as a private IP address? Private IP address, okay? So select 2. Private, the 10s, yep, that's cool. And 172.31.0. Okay, very good. All right. What portion of the 192.0.0.0 address is in the network portion? So, which portion of the 192 address? So the 192 is a if we're thinking classful IP addressing, okay, so that's a class C address, okay, class C. So the first three octets, okay, so the first 3 octets. All right. Oh, yeah, okay, that's, yeah, you got me on that one, Billy. All right. I guess I didn't look at that one too closely. That's fine. Which of the following is true about the classful address 128.44.2.2? The network ID is, so 128 would be, it's a class B, right? Yeah, it is class B. Yeah, it's class B. First valid. Mind blown. Go with that one. Damn it, I was right too. Epic fail. How's that? Oh, all right. We're getting there, guys. We're getting there. All right. Which of the following IP address / mask combinations, if configured on a working router interface, would create a connected route for an entire classful network instead of a route for a subnet of a classful network? Which of the following IP address / mask combinations is, if configured on a working router interface, would create a connected route for an entire classful network instead of a route for a subnet for an entire classful network? 172.168.1.1/24 and 172.16.1. That's right? Yep. All right. What is the Class A network ID of the host shown on the single local area network figure? What is the Class A network? So that'd be what is the Class A network ID of all the hosts shown in the figure? I had a feeling it was that one too. Man, I'm getting stumped up here. I don't know why I'm biffing this one. I'm biffing hard all of a sudden. I should have just said class 8. I knew it was 10. I knew it was the old 10s. Ah, all right. If subnetting network 192.124.10 dot with mask 29 for all subnets, what is the broadcast address for the 5th subnet? Oh boy. Subnetting is so much fun. Ah! So /29 is 248. Oh, 245. 245. 245. 248. Okay, 192. 224. 10.0. So 256 minus 248. All right, gets us 8. Okay, so we're going to go up by increments of 8. We have 0 to 8, all right, which would be 7. So then we have 16, 15. 8 plus 16 is 20, 24, so it'd be 23. So it'll be the 5th. We're looking for the 5th one, right? So, and then 8 plus 24 is 32, 31. And the next one would be 40, so it'd be 39. All right. Fifth one. 30, 39. Okay. Yep. 1, 2, 3, 4, 5. Yep. All right. Which option correctly lists the address covered by the indicated address class? Select 2 answers. Address class. Okay. So we're gonna think classful. Okay. That's wrong. This one's right. 192.223. All right, that's a class. That's class C right there. And then 128. All right, 128 to 191. Okay. Giving a mask 255.25.0, which of the following statements are true? There could be 254 possible hosts on the subnet with that mask. There is not enough default masks. This is not a default mask for a Class A network. That's true. If Class B network had this mask, up to 255 hosts could be created. This is not so. This is not a default mask for a Class A network. Which of the following, what are the default masks for each class network? Nope. Yep, that one. An engineer first confirms that a router interface 501 is up and working. He then configures the interface with the IP address 10.101.101.111.255.255.128 command. Then the engineer leaves configuration mode and issues the show IP route command. Which of the following masks would list the output that describes the connected route that exists as the result of the IP address? Okay. So the 128 would be the /25. How many bits are used for subnetting in a mask based on this example here? So how many bits are used for subnetting with the subnet mask 128? So we got how many bits? How many? All right. How many bits are used for subnetting? Subnetting in a subnet based on the sample. Okay, so let's take a look here. All right, so we have 2 for 5. Oh, what's up, baby? You're on break? I love your face. 2 for 5. 128.0. All right, so if we look at this subnet mask, this is all ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 128. 128, we're only, what are we at? 17, okay. So 16, so we're at 1, 0, 0, 0, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. All right. And then our address is 125, 168. All right. 168, 3299. All right. So we have a remaining. So we have 17 bits in our network. So that leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, right? Seven, 1, 2, 8, 8. Yeah. How many bits are used for? How many bits are used for subnetting? Are used for subnetting in a subnet based on this information? Okay, so if 125, so let's look at the class. So this is 125, so that would fall into the range of it being a class A network. Okay, so a class A network. Okay, so we have 8 and 9. So we have 9. 9's the answer for this one, guys. A little confusing, but it's 9. Okay, sorry, I had to think about how that question was trying to get me. All right. Giving a prefix length of /29, what is the correct dotted decimal notation? So /29 will get us to 248, 248, 248. When looking at an address using a classful addressing rules, how do you know the length of a prefix? When looking at an address using classful addressing rules, how do you know the length of the prefix? By looking at the number of host bits, by looking at the amount of bits, by looking at the first two octets, by looking at the amount of bits that are binary ones in the mask. Looking at a classful address. I'm gonna go with this one. That was right. What is the prefix notation for /2525252 /0? All right, so 252.0. So 252.0. What do we got? We got /22. All right. The figure shows an internet network with IP address and default gateways on some devices. The addresses have been configured on a router and PCs. The addresses have been configured on the routers, and the PCs have been configured using the same subnet mask as the routers in the local area networks. A router protocol has been enabled, and both routers have learned all routes known by the other routers. Which of the following statements are true about the behavior in the IP network? Okay. What do we got? What do we got? What do we got? 28. 3. 30. With the two IP addresses assigned, R3's local area subnet allows 14 IP addresses. All right, so we got to do some math on this one too, guys. All right, so router 3, how many? So what do we got? 172. Oh, what's that? 2 for 5, 2 for 5, 2 for 5, and then 2 for, and then 28. So 28 gets us to 240. 240 gives us 14. Yeah, so 14. That gives us 14 addressees with 2 IP addresses assigned. Oh, wait, that's wrong. With 2 IP addresses assigned, router 3 subnet allows for additional, no, it only allows for 12. With 2 IPs assigned and R3's subnet allows for 30, no. A new PC added to R1's LAN could be assigned IP address. Default gateway to allow PC. New PC added to one's IP address. All right, so we don't have to figure out that one. Let's figure out the router 1's local area network. That's the one we got to figure out. So router 1's local area network, we got a /23 notation. So /23 gets us to 254. So 2 for 5. So 2 for 5. 2 for 5. 254.0. They got a 110.4.4.200. Okay. So we got going up by 2's here. So 0, 2. All right. 2, 4, 6. So this range is falling in between these two right here. So we got a 5. Okay, so there, the subnet ID for this one is 10.4.4.0. All right, and its broadcast address would be 10.4.5.255. Okay, so what could it be? What can we get an address out of here? Okay. So we can actually have an address of the 10.4.255. Okay, we can actually have this address because that wouldn't be the broadcast address. This one right here would be the actual broadcast address. So let's select this one and let's see if we're good. All right, we're good. All right, that's good. I'm happy with that one. All right. A customer support rep at the help desk is working a problem. The problem records mentions address 172.16.1.1 with default mask 25255.254. At lunch, at a luncheon learning session yesterday, the rep heard the network engineer team say that they avoided variable length subnet mask and used only one subnetting mask in the network. 172.16.0.0. Which of the answers is accurate regarding the implementation of the 172.16.0.0 in the subnetting plan? The recorded mentioned address of 172.16. All right. So let's break this down real quick. Okay. So we have 2 for 5, 2 for 5, 54.0. Okay, and we have the IP address 172.16.1.1. All right, so we're gonna go up. We're gonna be going up by 2 0 so 0 2. All right, and then we're gonna be falling in between there. So this would be 1. So we have 172.16.1.0, and then 172.16.1.255. Okay, so we have an address range that allows us for 254 address, 254 host. Okay. All right. Which of the following answers is accurate regarding the implementation of that network? Okay. Network supports 256 subnets. The network supports up to 128 subnets. Each subnet supports no, each subnet would support the network itself. So if we were to do, we have so then we should also think about this because this is network, obviously. Well, and then if we were to think about this, classful, we would have 16 subnetting bits left over. So let's do some math real quick. 216. Oh, how did I? What am I doing wrong on this one? This. That one's a confusing one. Aggravating, that one. All right, let's move on. The diagram shows a small network with 3 VLANs. The network engineer needs to assign IP address to the host to allow them to communicate with each other. Which 2 of the following answers accurately describe the requirement for the addressing in the small network? Okay. The diagram shows a small network with 3 VLANs. The network engineer needs to assign an IP address to the host to allow them to communicate with each other. Which of the following answers accurately describes the requirement address for each? Okay, so PC31 and address must be in a different subnet than PC22. Yep, that's cool. If PC32's address is 192.10.99.8.7, okay. PC11 is assigned an IP address. Okay, so it's one of these 2. Figure out these 2. If I figure out one, the other one will be wrong. So I just have to figure out one. All right. We're doing good though, guys. We're doing good. 2 for 5. Definitely gonna need more coffee after this. 2 for 5. 2 for 5. 2 5 2. 5 0. So we're going up by 4s. Okay. So 10, 99, 8, 88, 77. All right, so 0, 4, all the way up to 88. So 88, and then the next one would be 88. The next one would be 90, 92, right? Yeah, 92. So it'd be 91. That's the broadcast. So this would be 10.99, 88.0 to 10.99. So I'm gonna choose this one, because that would work. Ah! Oh, damn it, Joe! You didn't look at the freaking answer. Ah! Going too fast now at the very end. Which IP address could be used to the host of the subnet? Man, not looking at things. I'm rushing now. I'm rushing. It had a totally different subnet mask. Dummy. So /29, 248. I get mad at myself when I do this stuff, guys, and I beefcake it. But that's what these reviews are about, guys. It's getting better, getting smarter every time, you know. That's it, guys. That's what we're doing this for. So, goes into that. So 48, 56, 5. So 151, 192, 850, 151, 192, 8. Oh wait. Yeah, 8, 5. Which IP address could you be used for the host in 192? So what do we got? No, no. This one's good. Yeah, this one's good. Okay. Let me unbrain fart myself, guys. All right. Figure shows the internet network IP address and default gateways on some devices. The addresses have been configured on the routers, and PCs have been configured using the same network mask as the router as the protocol. All right, here we go again. Select two answers. PC3 should not be able to ping PC1. PC3 is in a different subnet. Subnetting questions. Gotta love these subnetting questions. All right. /27 gets us to 224, 224. All right, 256, 224. All right, what do we got? We got 2, 3, so /32. We got 192, 68, 11, 77. All right, so we got 0, 32, 64, 90. Six, 5. Okay. All right, so what do we got? Yeah, it's in a different subnet, totally different subnet. Okay. Mm-hmm. Which of the following IP address could be assigned to a host? Which of the following IP address could be assigned to a host? Oh, back. Ooh, me back. All right, so 214 can be assigned. Yep, that can't be. This can be. This can't be, so it's one of these two right here. Go with these two. What is the broadcast address for the subnet that hosts 172 172.22.18.25.25.254.0? So 2.22.118. Yeah, like go back to my subnetting roots. So we're gonna be going up in increments of 2 here. So 0, 2, all the way to 118. 118. So the subnet ID, subnet. What are we looking for? The broadcast address. So it'll be 120. So it'll be 119. To which subnet does 168.148.76/29 belong to? Okay, let's write that one down. So /29 gets 248, so 2 for 5. 2 for 5. 2 for 5. 248. 256 minus 248 gets us 8. So 192.168.48.76. Okay. So how many times is 76 going to 8? So 76 divided by 8. 9 times 8 equals 72. So we have 72, and then 96. Right. No, 80. I mean, 80, so it'll be 79. All right. So 72 on this one. Fifth on a couple of them. Hardcore. Some of them, it's like I knew the answers too, and I just totally picked the wrong answer. It's okay. I think we did actually pretty good. Hey, we did pretty good. Woo! We got a 941. So we did pretty good. Either way. I'm pretty happy about that. Not happy that I got some wrong. But nonetheless, I'm still pretty happy on how we did. Let's just go to the question review. So it's about chapter 12 that we started having issues here. Chapter 13. It doesn't look like it gave us any questions for chapter 15, 16, and 17, even though I thought I selected them. But either way, that was a good review, guys. Something that I needed to do. As always. Close that down. Close this down. Close that out. All right. Now we can get into, we're going to start on OSPF. Me 1 second. Let me just clear up my table real quick. Everybody doing all right? All right. Grab my phone. Plug this guy in. All right, we got coffee still, so we have some hot coffee. We got a drink. Move this. Write this down. Let's get back here. All right. Well, we're back over here, guys. All right. So we're going to start talking about OSPF. All right, and we'll get into. Ooh, my hair is all messy. We're gonna get into just reviewing some of it, and then we'll lab it up real quick. And then we're gonna call it. We'll call it a night from there. All right. Just get some coffee because I gotta get ready for work tonight too as well. How's everybody doing though? Hope everyone's doing good tonight. That was a good review. I hope you guys feel the same way. All right. So, all right. So part six begins the story in this book about. So part 4 began the story in this book about IP version 4, IPv4 addressing. Part 5 continues that story with how to implement addressing in Cisco routers, along with a variety of methods to route packets between local interfaces. But those topics delayed the discussion of one of the most important topics in the TCP/IP, namely IP routing. All right, routers use IP routing protocols to learn about the subnets in the internet network. Choose the best routes to each subnet and to add those routes into each router's IP routing table. Cisco chooses to include one and only one IP routing protocol in the CCNA 200-01 exam, the Open Shortest Path First Routing Protocol, so OSPF. This entire part focuses on OSPF as an example of how routing protocols work. Okay, let's read that again. Cisco chose to include one and only one IP routing protocol in the CCNA 200-301 exam. So OSPF would be the only routing protocol that we need to examine and to go over. Okay. All right. So the entire part focuses on OSPF as an example of how routing protocols work. Okay. All right. Chapter 19, determining, obviously the chapter covers the following exam topics: IP connectivity, determining how a router makes informs decisions by default, administrative distance, routing protocol metric, configuring and verify single area OSPF version 2, neighboring adjacencies, point-to-point, broadcast, DR and BR selections, router ID. Okay. This chapter takes a long look at Open Shortest Path Open Shortest Path First version 2, OSPF version 2 concept. OSPF runs on each router, sending and receiving OSPF messages with nearby routers. These messages give OSPF the means to exchange data about the network and learn and add IP version 4 routes to the IPv4 routing table of each router. Most enterprise over the last 25 years have used either OSPF or Enhanced Interior Gateway Routing Protocol, EIGRP, for their primary IPv4 routing protocols. For perspective, both OSPF and EIGRP have been both part of the CCNA throughout most of its 20-year history. For the CCNA 200-301 exam blueprint, Cisco has included OSPF version 2 as the only IPv4 routing protocol. Note that Cisco does include EIGRP in the CCNP Enterprise certification. This chapter breaks the content into three major sections. The first section sets the context about routing protocols in general, defining the interior-exterior routing protocols and basic routing protocol features and terms. The second major section presents the nuts and bolts of how OSPF works, using OSPF neighbor relationships, database exchange, and then the route calculation. The third section wraps up the discussion by looking at OSPF areas and LSAs. Okay, let's do the "Do I know this already?" quiz real quick. Which of the following routing protocols is considered a link state? So a link state logic. So link state. It's funny because I just reviewed this. Which of the following routing protocols is considered to be a link state? I need to know this too. So it's OSPF. I'm going to say OSPF because RIP is a vector state. A vector state logic. Vector. All right. Which of the following routing protocols uses a metric that is by default at least particularly affected by the link bandwidth? Choose two answers. So which of the following routing protocols use a metric that is by default at least particularly affected by link bandwidth? So we'll go with EIGRP and OSPF. So we'll go with C, D on this one. Which of the following interior routing protocols support variable length subnet mask? Variable length subnet mask. We'll go with B, C, and D, I think. So B, C, and D. Two routers using OSPF version 2 have become neighbors and exchanged all LSAs. As a result, router 1 now lists some OSPF learned routes in its routing table. Which of the following best describes how router 1 uses those recently learned LSAs? Which of the following best describes how R1 uses those recently learned LSAs to choose which IP route to add to its IP routing table? Which of the following best describes how R1 uses those recently learned LSAs to choose which IP route to add to its IP routing table? LSA lists a route to be copied to the routing table. Some LSAs list routes that can be copied. Run some SB math against the LSAs to calculate the routes. R1 does not use the LSAs at all when choosing what routes to add. Link state. What does LSA mean? I don't want to look. Let's go with A. Let's go with A. Which of the following OSPF neighbor states is expected when the exchange of topology information is complete between OSPF neighborships? Which of the following OSPF neighbor states is expected when the exchange of topology information is complete between two OSPF neighbors? States is expected when the exchange topology information is completed between OSPF neighbors. Oh, okay. Is it up, or is it full? It's either up or full. I'm gonna say full. Maybe. A company uses a small, medium-sized network with 15 routers and 14 subnets and uses OSPF version 2. Which of the following is considered an advantage when of using a single area design as opposed to multiple area design? It reduces the processing overhead on most routers. Status changes to one link may not require SBF to run on every router. It allows for a simple plan of operation. It allows for route summarization, reduced size. Company has a small to medium-sized network with 15 routers and 40 subnets and uses OSPF version 2. Which of the following is considered an advantage of using a single area design as opposed to multiple area design? It allows for router summarization, reduce. I think it reduces the processing overhead of most routers. Because OSPF, I want to say, is processor dominant. That's one of the disadvantages of it. All right. Yeah, I got it wrong. Allows for an easier plan. Okay, so I think we did all right on some, but we did get some wrong. So we got D, so we got that right. So we got, who? Too big. So we got D, first one right. CD, second one right. B, C, D, third one right. Oh, we got this one wrong. Okay. So this was supposed to be C. We got B right, and this was supposed to be C. Okay, so let's just take a look at what we got wrong. So it allows for a simple planning of the operation. Okay, I get that. That's cool. Yeah, exactly. And then we got 4 wrong. Run some SPF math against the LSAs to calculate the routes. Okay, so we got 2 wrong out of the 6 questions. We did okay. We still need to review the entire portion here. Okay, me just swallow some coffee. All right, if you're just joining, hello everybody. So we just started, what are we at, chapter 19? We just started the review of chapter 19. We went through the entire Pearson test prep. We got a 941 out of 1,000 score. We did 102 questions to start the stream to review on. Right now we're jumping into the chapter all about OSPF, open shortest path. All right, first. All right. Goodbye, everybody. All right. So comparing dynamic routing protocol features, routers add routes to their routing tables using three methods: connected routes, static routes, or routes learned by using dynamic routing protocols. Before we get too far into the discussion, however, it's important to refine a few related terms and clear up any misconceptions about the terms routing protocols, routed protocols, and routable protocols. The concepts behind these terms are not that difficult, but because the terms are so similar, and because many documents pay poor attention to which of the terms is used, they can be a bit confusing. These terms are generally defined as the following: routing protocols, a set of messages, rules, and algorithms used by routers for the overall purpose of learning routes. The process includes the exchange and analysis of routing information. Each router chooses the best route to each subnet, path selection, and finally places those best routes in the IP routing table. Example includes RIP, EIGRP, OSPF, and BGP. All right, routed protocols and routable protocols. Okay, both terms refer to a protocol that defines a packet structure and logical addressing, allowing routers to forward or route the packets. Routers forward packets defined by the route in routed protocols. Example of IPv4 and IPv version 6. Okay, so let's read those two terms. So we have routing protocols and routed or routable protocols. All right, routing protocols, a set of messages, rules, algorithms used by routers for overall process of learning routes. Process includes the exchange and analyze routing information. Each router chooses the best route to each subnet, path selection, and finally places those routes in the routing table. An example includes RIP, EIGRP, OSPF, and BGP. Routed protocols and routable protocols. Both terms refer to a protocol that defines a packet structure and logical addressing. Okay, packet structure and logical addressing. Okay, allowing routers to forward or route the packet. Routers forward the packets defined by the routed and routable protocols. Example is IPv4 and IPv6. Okay, note the term path selection sometimes referred to part of the job of the routing protocols in which the routing protocol chooses the best route. All right. Even though routing protocols such as OSPF are different from routed protocols such as IP, okay, they do work together very closely. The routing process forwards IP packets, but if a router does not have any routes in its IP routing table that match the packet destination address, the router discards the packet. Routers need routing protocols so that the routers can learn all possible routes and add them to the routing table, so that the routing process can forward routable protocols such as IP. So again, routers need routes in their routing table to route packets. Okay, if they don't have a route that matches a path to which a IP packet needs to flow to, that router would discard that packet. It'd just get rid of it. It'd drop it. Okay? All right? All right. Let me pour the last bit of my coffee. I'm just trying to drink my coffee before it gets cold, guys. That's it. So. All right. Let me you know what I'll do? Let me pull up YouTube here, just in case you guys are messaging me on YouTube. I would hate for anybody. I would hate to miss anybody on YouTube chatting it up. So if you guys are over on YouTube, you're chatting it up. I am monitoring YouTube on my phone and Twitch on my PC here. So, all right. Routing protocol functions. Cisco iOS software supports several IP routing protocols performing the same general functions. All right. Learn routing information about IP subnets from neighboring routers. Advertise routing information about IP subnets to their neighboring routers. If more than one possible route exists to reach one subnet, pick the best route based on the metric. If the network topology changes, for example, a link fails, react by advertising that same route has failed and pick up a new currently best route. The process is called convergence. Okay. Note a neighboring router connects to the same link as the other router, such as the wide area link or the same Ethernet local area network. Okay. The figure shows the example of 3 of the 4 functions in the list. Our router 1 in the lower left of the figure must make a decision about the best route to reach the subnet connected off of R2. On the bottom of the figure, follow the steps to the figure. R2 advertises a route to the lower right subnet 172.16.3.0/24 to both R1 and R3. After R3 learns about the route 172.16.3.0/24 from R2, R3 advertises that route to R1. All right. R1 must make a decision about the 2 routes it's learned about reaching the subnet 172.16.3.0/24. One with one metric from R2 and one with the metric 2 from R3. R1 chooses the lower metric route from R2, function 3. Okay. The other routing protocol functions convergence occurs when the topology changes. That is when either a router or a link fails or comes back up again. When something changes, the best route available in the network can change. The convergence simply refers to the process in which all routers collectively realize something has changed, advertise the information about the change to all other routers, and all the routers then choose the currently best routes for each subnet. The ability to converge quickly without causing loops is one of the most important considerations when with IP routing protocol is used. Okay. In the figure, convergence might occur if the link between R1 and R2 fails. In this case, R1 should stop using its old route from 172.16.3.0 directly to R2, okay, and then begin sending packets to R3, okay. All right. Interior and exterior protocols. You know what we'll do? Let's do this. We got this up right now. Let's start. Let's make a topology, guys. Let's get it started at least. All right, we'll use the same. We'll use a similar topology on which those routers and that scenario are using. Okay, guys. Let's move this down just a little bit. Like this, and we'll add some PCs. Anytime, questions. If you guys have any questions at all, what I'm using, what I'm doing, just always feel free to ask. And then we'll go from there, okay? And what was the topology? This was R3, right? This was R3, this was R1, R2. Okay. Your hub 1, PC1. Three. PC3. Hub 2. PC2. Let's get these fired up. We'll get that fired up, and as we're going over, as we're talking, we'll give that a couple minutes to finish its boot. All right. All right. So in the topology, as it's going over here, what do we got? So in the figure, convergence might take a little bit between R1 and R2. So R1, make that smaller. No. That's not what I wanted to do. I want to erase that. There we go. All right. It's smaller. All right. So R1, R2. All right. Sorry about that. I could change my whole thing into a blackboard. It's not what I wanted. All right. In the case, if R2 fails, so if R2 fails, okay, R1 should stop using the old route. So it should stop using the route between this link right here. For the old subnet 172. So it's talking if this link right here were to fail, okay, and it still probably needed to get to this possible subnet, okay, directly through R2, beginning start sending packets. So what it's stating is it should then start sending packets back up to R3 on R3's interface, and then R3 should start sending packets to this interface down here. So what we'll do is we'll create this similar topology, all right, and we'll create it. We'll create same type of subnetting here, and we'll have it all working with OSPF, and then we'll grenade this link right there on our topology, and then we'll see. We'll then take a look at OSPF and how OSPF is making these adjustments and making these reconvergences to make things still work. Okay. All right. Because lowest metric has the lowest metric. One. And then we'll also take a look at the cost and all that too. Well, I guess this isn't really talking about cost. This is just more talking about the convergence of things. So that's what we'll talk about. All right, so we're up. These are coming up right now. They should be done here very shortly. Bum, 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 bum. All right. These are up now. Let's give it one more second to finish its. Even though it looks up, it still takes like another second or two to finish its whole boot phase. All right. Is it gonna do it? Is it not gonna do it? Yeah, it's still slow as heck. Give that one more second. All right, so let's just write down. Let's get some information off of what we got going on for routes for some information we got over here. So gigabit. So here we go. R1's next hop is this right here. Subnet. So what do we got? All right, so we're gonna have to just make up something, but we have some information. Okay. So we have some information. So R2, we're just gonna say R2, all right, has the subnet of 172.16.3.0/24. That's off of the gigabit interface. Okay, so we have that. All right, this interface off of that one. Actually, R2 is again. So we'll say 172.16.6.252. All right, that's off its gigabit 0-0 interface. And then we have another, it has another subnet of 172.16.2.252. Okay. Very good. All right, so we have, it has, we're going to use that address plane. And we're going to say off of R1 has the 172.16.1.0/24 off on its interface. Okay. We'll just have to, so this will be the same linkage on that one. So I'm just going to draw a little line. With this, that one right there, that's going between R1 and R2. Okay, do this. R1, R2. Come back over here. We'll draw the line from here. All right, we'll go back here. We're gonna say R2 to R3. All right, this should be right there. We have that one covered, and then we just need a subnet for. All right, we're gonna say this would be our subnet for this link right here from R3 to R1. So let's say 172.16.4 .252. 252. There we go. And that would be the link between those R3 and R1 over there. All right. Same thing again. So we're gonna say R3 and R1, and that a complete R1. And that should set us up. That should give us enough information for what we need, and then off of R3's interface. We're just going to say 172.16.5.0/24. All right, just to give that a just to give that its own little thing, even though we don't have that information, but we'll use this information so we can create that topology over here in CML. Okay. All right. All right. Where are we at? 3. So let's make some connections. Each 0 will be to its own subnet. Okay. And then I'll say 2 to 2, 1 to 1, and we'll say 2 to 2. Keep things simple. Okay. So there we go, right there. All right. So we're in router 3 right now. Okay. So in router 3, let's go to configuration terminal mode. Let's give this a quick host name of R3. Okay. So we can remember things. All right. Let's go to its interface, gigabit 0-0. We're going to give this an IP address. That's going to be the 172.16.5.1, 5.25.5.0. Say that's no shut. All right. Now let's go into the link between R2 and router 3. It's 252. All right. So let's do this. Interface gigabit 0/2. IP address. What's the link between R2 and R? So we're going to say 172.16.6.25. We'll say 253 on this link, and whatever, we'll give it the /0. Doesn't really identify the subnet mask. It don't really matter at this point. No shut. Okay. And then the interface gigabit 0-1. That's going to router 1, and that is 172. IP address 172.16.4.253 again. Okay. Now shut. Okay. Interface loopback. All right. Let's give our loopback address here. Let's give it the loopback address of 3.3.3.3 25.5.25. Okay. Now let's give this a little DHCP for our PCs. IP DHCP pool net 1. All right. Network 172 16.5.0 25.25.0. Default here is 172 16.5.1. All right. Let's exit. All right. Now let's make OSPF work. Router OSPF version 1. Network, we're going to say 172.16.0.0, 0.0.25.25, area 0. Okay. Exit. Do right. That finishes that one. All right. Very good. All right. All right. Let's come over to here to R1 now. All right, host name. I'm going to say R1. Very good. All right, interface, gigabit, 0-0. Same thing. We're going to do blast this out real fast, guys. Interface. So we're going to say 172.16.1.1, 25. 172.0.0. No shot. Interface, gigabit. Which one was going? Let me just look real fast. Our one is going to 3. Okay, very good. (0-1). All right, IP address. What's that again? That's the 172.16.4. So 172.16.4.252. All right, 255.255.255.0. No shut. All right, interface gigabit 0-2 now. All right, moving too fast for all of this. All right, IP address 172. Now this is the link going to R2 172. So that's 2.252. So 172.16.2.253. All right, 255.255.255.0. All right, no shut. All right, now let's give this a loop back. Interface. Loop back. 1 IP address 1-1-1. 1.255.255.255. All right, IP DHCP pool net 1. All right, this is just for that PC. All right, network 172.16.1.0, 255.255.255.0, default 172.16.1.1. All right, exit. Now let's make OSPF work. Router OSPF version 1. Network 172.16.0.0. 0.0.2525, area 1, area 0. All right, exit. Look at that. All right, we already made a convergence over here. All right, loaded full. All right, let's do a do write. Let's write that configuration now. All right, so our R1 is done. Now let's finish up R2. I thought it broke on me again. All right. Comfort D. All right. Host name. Host name R2. All right. Interface. Gigabit 0-0. IP address, and that's going to be that host IP address off of that is the 116.3.0. So 172.16.3.1.25.25.0. No shut. Okay. Interface gigabit. I gotta look real quick. So gigabit 2 is going to R1 and gigabit 1. So let's start off with gigabit 1. So gigabit 1 is going to R3. And what's that network, guys? That's the that's the 6. All right, so gigabit. I gotta look at that again. Okay. 1 is going to 3, and then 2 is going to 1. 0-1 IP address 172.16.6.252.25.25.0. No shut. Okay. Interface gigabit 0-2. Okay. IP address 172. What's the link between R1 and R2? Is the 2s. 172.16.2.252.25.25.25.0. No shut. Okay. Interface loopback 1. IP address 2.2.2.2. 25.25.25. Okay. Let's make a DHCP IP. DHCP pool net 1. All right. I'm going to say network 172.16.3.0. That's 255.5.0. Default 172.16.3.1. All right. Exit. All right. Now let's make OSPF work. Router OSPF version 1. All right. I'm going to say network 172.16.0.0 0.0.0.0 5 area 0. All right. Exit. All right. All right. So we just made our adjacencies to both routers. Let's do right, and let's clean up the board. Now that we have everything that we should have up, we can clean that up. Lower this down a little bit. All right. Let's connect our PCs up here. All right, let's fire up these PCs. Finish my coffee. Ah, that's cold as heck. Oh. All right, so let's take a look at do show IP route. Let's take a look at our routes. All right, so if we take a look at our routing table right now, we can see we have a couple things learned by OSPF here. Okay, so we have the 192.168.1 network. Okay, the 192.116.2 network. Okay, all learned via OSPF. Okay, so we have OSPF learning routes already. Okay, which is excellent. So let's go over to our PCs. Okay, let's do an IP address. Let's look at our IP addressing. Oh, and we have it'd be better if I turn on these hubs. I forgot to turn the hubs on. You can't do anything if you ain't got the hubs on, buddy. Give those hubs a second to turn on. All right. I don't know if I might have to turn off these interfaces. No, all right, we're good. So we got IP addresses now. So we got an IP address in the correct range. Let's go over to these PC. Should make sure we got IP addresses in everywhere. All right. Yep. Cool. We got IP addresses. So, all right. Now let's try from PC2. Let's try to ping PC3 up here, and that has the IP address. So I'll write it for you guys. So we have some context-sensitive help here. So that has the IP address. Make that just a wee bit smaller. 172.16.5.2. All right, and then this guy over here, I believe his address is 172.16.1.2. All right, because this guy's address is 172.16.3.2. And I'll just confirm that real quick. Yeah, 1.2 and 5.2. Okay. All right. Let's see if we can from PC2. Let's see if we can ping. Let's see if we can ping 172.16.5.2. Hold on. All right, look at that. All right, so we can ping. We can already ping. So we already got some. Now let's do a trace route on that. Let's do a trace route on 172.16.5.2. Let's see what it's doing. Let's look at where we're hopping. Okay. So, you know what I should do? We should write down the interface numbers too. That way we can see it. That's what we'll do next. All right. So let's do that. All right. Let's write down some interfaces. All right. So let's do this. Let me do show IP interface brief. All right, so let's do this. So this interface, this is going to. So we already know this one is the 172.16.5.1, and going to. I just have to take a quick look at what the other interfaces were. So one's going to 1. Okay, one's going to 1 and two's going to 2. Okay, let's have a look at that again. So one's going to 1. So 1 is 172.16.4.253. So that's 1. All right, and then this interface is 172.16.6.253. Okay. All right. All right. So that's that. All right, so we have all that written down. Now let's come over here. All right, do show IP interface brief. All right, let's write this down now. So remember, so this interface is the 172.16.1.1. All right. So that's this interface right here. I'll kind of just leave it here. That way it doesn't get in the way of anything else. And then we have the 172.16.4.252 right here. And then over here, we have the 172.16.2.253. 253. Okay. All right, so that's routers info. Let's go back over here. Do show IP interface brief. All right, let's get some information on this one now. And then we'll take a look back at that trace route. So 172.16.3.1. Very good. Move that over just a wee bit. And then what do we got on this interface? So that is the 172.16.2.252, right? This bottom interface, and then on this top interface, we have 172.16.6.252, right? All right, very good. So there's our breakout of our interfaces. So let's take a look back at how this trace route, how it went, okay? So 3.1, so when we pinged PC3 over here, all right, is that the PC that we pinged? Yeah, so we pinged this PC up here. All right, so we went to 3.1. From 3.1, we went to 253, okay? So we went to 172.6.253, all right? And then obviously we made it back to that. So we went from here to here to here, okay? So pretty much it's shortest path, okay? Shortest route, all right? Again, now let's do another trace route. All right, trace route, we're gonna say 172.16.1.2. All right, so we're already getting some information back. All right, so as you can tell from just the residing information, so from 3.1, so we went from 3.1, okay? So 3.1 here, 3.1, all right, to 172.253, 172.253. So this interface on router 1, okay, all right, to the final destination 172.16.2. Okay, all right. So OSPF is doing what it's supposed to be doing. Okay. Now let's do this. Erase these real quick. Now, to get back to what that was stating is, let's come over here. And which interface is going to router 1? That is the 02. Okay. So let's go to interface gigabit 0-2. Yeah, 0-2. And let's give that the shutdown command. Okay. All right. Now let's take a look at the routing table. So do show route. All right. Do we still have a route for the 17? Yep. So it's pretty much, so it changed the route now to the 172. All right, so it changed the route from the 172.253, all right, to the 172 via 172.16.4.3. All right, so now let's go back over to the PC now. Let's go back over to this PC. Let's do a trace route on that same PC now, and let's see what we get for information. So as you can tell, things have changed, okay? Look at that. Beautiful, 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 beautiful. And this is how OSPF is making those changes, okay? OSPF is actively making changes, okay? And that's why OSPF is so awesome in comparison to statically addressing things, okay? So look at that. I didn't have to change anything in my routes or anything like that. I just allowed OSPF to make these dynamic decisions. So we did the same thing. So we, from PC2 to PC1 over here, okay, we did the same exact trace route, okay? So on the first one, we pretty much went from R2 to R1 all the way to PC1, okay? Now, when we took down this link, remember, we did a shutdown command on this link, pretty much cutting that link off, okay? So instead, we went to 172.16.253. That's an awful straight line. I'm awful at that, so let me just get my straight line tool. Boom. So 172.16.6.253. So we went to R3's router interface, okay? Then we went to 172.16.252 to R1's interface now, and then to the host at 172.16.12, okay? So we had to make one more additional hop, all right? But dynamically, OSPF was able to adjust to the changes in our topology, and we were still able to route, all right? That's the dynamicy of why OSPF is such a great tool, a great protocol to have within your network. Okay, all right. So yeah, so that pretty much covers the initial I guess introduction to OSPF here. So yeah, so as you can tell, how we created this same topology using the same logic that topology was referring to, on how OSPF makes these changes dynamically. All right. And again, so we'll even do a do show route. Here's the original route. Remember, we did that beforehand. And we'll take a look at some of the changes that we've had. So to get to the 3-dot network, well, this one might actually stay the same. Yeah, that one actually stayed the same because it still has its link going to 116 6.252. All right. Yeah, and that stays the same on that one because we didn't destroy that link. All right. All right. But yeah, so any questions so far on again? This is just the introduction to OSPF, guys. We haven't got into anything nitty gritty. Like, let me just save these configurations real quick. Save them. Not a beer. It's a seltzer water. All right. All right. Interior and exterior routing protocols. IP routing protocols fall into the two major categories: interior gateway, IGP, interior gateway protocols, IGP, and exterior gateway protocols, EGP. Okay. All right. The definitions of each are as follows: IGP, a routing protocol that is designed and intended for use in a single autonomous system, AS. All right, EGP, a routing protocol that was designed and intended for use between different autonomous systems. Okay, EGP. The term IGP and EGP include the word gateway because routers used to be called gateways. Okay, so routers used to be called gateways. Okay, these definitions use other new terms: autonomous systems, AS, autonomous systems. An autonomous system is a network under the administrative control of a single organization. Okay, so you can think of it as an autonomous system as being a network, a defined network. Okay, that's an autonomous system. Okay, for example, a network created and paid for by a single company is probably a single autonomous system, and a network created by a single school system is probably a single autonomous system. Other examples include large divisions of state or national governments. With different governments, agencies might be able to build their own networks. Each ICP, ISP, Internet Service Provider, is also typically a single autonomous system. So each Internet Service Provider is typically a single autonomous system. Okay. Some routing protocols work best inside a single autonomous system by design. Some of these protocols are called IGPs, interior gateway protocols. Conversely, routing protocols designed to exchange routes between routers in different autonomous systems, okay, are called EGPs, exterior gateway protocols. Okay, border gateway protocols, BGPs, is the only EGP used. So border gateway protocols, okay? Border gateway protocols is the only EGP used. So we're using BGPs, okay? Each autonomous system can be assigned the number called, each autonomous system can be assigned a number, unsurprisingly, as a ASN number. So autonomous system number, ASN. Let's say that again. Autonomous system number. All right, ASN. Like public IP addresses, the Internet Assigned Numbers Authority, the IANA, all right, controls the worldwide right to assigning ASN. So autonomous system numbers. All right. It delegates the authority to other organizations around the world, typically the same organizations that assign public IP address. For example, in North America, the American Registry for Internet Numbers, the ARAN. I love acronyms. Woo! They make your head blow up. ARIN, the IRIN, assigns public IP address ranges and autonomous system numbers. Okay. The figure shows a small view of the worldwide internet. The figure shows 2 enterprises and 3 internet service providers using interior gateway protocols, OSPF and IGRP, inside their own networks, and with BGP being used between the autonomous system numbers. Okay, so there's a nice little awesome topology here. So we have some autonomous system numbers. So we have autonomous system 100, autonomous system 300, 400. All right, inside of their interior network. All right, so the inside of their antenna and inside of their own interior, they're using such protocols as OSPF, EIGRP, or here we go, EIGRP and OSPF. But to communicate between each other, they're using BGP, Border Gateway Protocol. Okay, BGP, Border Gateway Protocol. Okay, to communicate between autonomous systems. Okay, all right. Comparing IGPs, organizations have several options when choosing an IGP for their own enterprise network, but most companies today use either OSPF or EIGRP. This book discusses OSPF version 2 with the CCNA Enterprise certification, adding EIGRP, both getting into details of those 2 protocols. This next section first discusses some of the main goals of every IGP, interior gateway protocol, comparing OSPF and EIGRP, plus a few other IP protocols. All right. So what we're gonna do is let's bookmark here, guys. All right, let's bookmark there. We've only got about a quarter of the way through this chapter, but that's all I intended to do, was just a quick introduction into this chapter, because again, I don't want to review the whole entire chapter and then over the weekend forget about what we've learned. All right, I like to hit entire parts, all right, into 1 week. All right, so what we're gonna do, just because I gotta get ready for work and I don't want to rush to get ready for work, like I have been, we're gonna end it here, guys. Tomorrow, well, what is it? Tomorrow's Saturday. We got Saturday, Sunday over the weekend. Again, depending on what I got going on over this weekend, because I'm gonna be working over this entire weekend again, as usual. You'll see me, if you guys are following me, you'll see me pop up on the stream and whatnot. Let's go to my other thingy. So we'll be over the weekend. We'll get up. We'll probably be streaming over the weekend and doing some more stuff. But yeah, so thank you guys again for another awesome week of studying. We did really great. We've made it very far so far. If you guys don't mind, let's hang out, guys. Let's hang out for a minute. I'm gonna go raid my. Let's go raid my boy La Leyenda. He's a cool dude. Make sure you guys, when you guys get over to his thing, you guys hit him up with a follow. I would greatly appreciate that, because La Leyenda is really an awesome dude. And you guys have a great weekend. I'll see you guys back. Again, I'll probably be streaming over the weekend, but either way, have a great weekend. And we'll be back getting into things back on Monday. All right. I want to thank again, you guys almost got me at 50. Let's get me over to 50, and let's get to Twitch 50, baby.